Good evening, everyone. So this is my presentation for A3. I will just share my screen. Um, 1 second. Share. Okay. Okay. So let's begin from the first slide. So my name is Patricia Beckham, and my student ID is 236452, and I shall be posting in my YouTube link after this. Okay, without wasting any time, let's move on to the next slide. So for project domain, so in this project, we were actually tasked with designing and implementing a relational database for the Australian Manufacturing Company, which is AMC. It operates multiple retail stores across Australia and deals with a range of entities such as employees, departments, stores, suppliers, patrons, products and orders. So our main goal was basically to create a structured database that would streamline the company's operations, enhance data security, accuracy, and support future software development. The database design focused on organizing business data using proper relational modeling techniques to ensure integrity, reduce redundancy, and support complex queries. Let's move on to the ERD design. So basically, the AMC ERD design. So this is our completed ERD. ERD design, which uses cross-foot notation. It includes 10 main entities and models all relevant business rules provided in the case study. The one key challenge was resolving many-to-many relationships. For example, a single order can actually contain multiple products, and a product can appear in multiple orders, right? So if you may see in the step one that I've shown, it shows a direct many-to-many relationship. However, this is not allowed in relational databases. So in order to solve this, we've introduced a step two, where we introduce a junction table called order detail. So you can see that the one in the middle. So this includes composite primary keys, which is order ID and product ID, and also an extra attribute, which is quantity, which is typical for solving many-to-many relationship. So when we actually break down the relationship into two one-to-many relationship, this allows us to link e-order and product using foreign keys. In this way, we can actually track quantities for each product in a specific order without redundancy. Now, let us look at a one-to-many relationship from ERD. I chose store and store to employee. So each store employs multiple employees. This relationship is modeled in the database with store having a primary key as store ID, and under employee table, it is including store ID as a foreign key. So this design links each employee to the store where they work, allowing us to capture which employees are assigned to which locations. So in the diagram, you can see a line connecting store to employee with a crossfoot on the employee side. This signifies the many side of the relationship. So in our table, in this store table, you can see that there are actually 5 different store: Rise and Shine, George Street Mall, etc., etc. So from the employee table, you can see that Albert, so there are, I think, five or six employees here. So you can see Albert, Michelle, Nancy, Bob, they all work for store ID 1. If you can see right on this side of it. Which is Rise and Shine, and then the other two, which is Sarah and Jackson. Jackson and Sarah, they work for store ID number 2, which is George Street Mall, right? So this clearly demonstrates the one-to-many relationship between store and employee. Let's move on to SQL query and output. I actually chose question number 2, list all the products having price less than 100. Okay, so in a SQL, you have to input this command, which is select per ID, which is basically product, per name, brand description, and price. So this will basically be your attributes, like your columns, right? Excuse me. From the product table, which is from product, and where, so this is basically a filtering clause, right? So where price is less than 100. So that is your query. And then once you, don't forget your semicolon, that will give you your, once you enter that in, that will give you this output: pro ID, pro name, brand description, and price. So it retrieves all products priced under 100 and displays essential details, and basically demonstrated simple filtering using a where clause. Right. So if you see all products that has been pulled from the table are actually below $100, right? Now, let us move on to reflection and contribution. So my responsibilities. So for this project, I was responsible for part A, designing the ERT. I identified all main entities, attributes, and relationships. I ensured the model was logically sound and aligned with the business rules. Although I efforts to assist with part B normalization, however, I respected the group roles and supported the assigned member to complete it. I'm also thankful for my team that submitted and reviewed the ERT with Madam when I could not stay back on Friday because I was late for other commitments. So lesson learned. So this project has actually taught me a lot about collaborative database design, handling many-to-many relationships, and integrating business rules into technical structure. Looking ahead into the future, I would like to explore linking the database with a web front end. Thank you for watching, and I shall be posting the YouTube link later on. Thank you.